of EV, because our thought process was if we want to address the theme of integrating AI applications with EV, the first core aspect that we should know is how we can model EV applications using MATLAB Simulink. Because if we can't model EV applications in MATLAB Simulink, so there is no use of building any AI applications because there is nothing to integrate with. So that is where we started with. So we addressed from the basics, like how we can do. We understood one of the important tool with which we work in industrial application is Simulink. We started with Simulink. We did modeling application. We modeled very simple idea. Let's say we want to do modeling. We started with mathematical modeling, and then I also showcased in EV there are a couple of apps through which you can easily simplify EV applications. So one application we did hands-on is called as, so it's in automotive, yeah, it's here. So virtual vehicle composer. So this is something we looked into yesterday at the end part of the session. So where we looked into how we can build EV architecture, automotive vehicle architecture, whether you want to build for core mechanical EV or if you want to go for hybrid vehicle or fully electric vehicle, we looked into how we can do those things. And then later also I addressed that along with EV system modeling, EV architecture modeling, when it comes to core electrical application, one more important aspect that we look also is building battery packs. So yesterday I highlighted that we also have a workflow available through which you can build, starting from modeling your cell till integrating it to the complete battery pack, how you can do with the help of something called as battery builder application. That is also we discussed. So this is what we covered yesterday. Now we are focusing on the AI application workflow. We'll switch over to AI applications today. That is what we'll do right now, because that is now one more area that is we have to focus on. So now how we can use our MATLAB environment to build AI applications, that is what we'll be so focusing on in this session today. So now since the background is set, first thing what we need to know is how we can start building AI applications, what and all libraries are available in MATLAB using which we can start building AI applications. So let us look into that. So in my case, I will open the help button. So on the right side, we can see whenever you open MATLAB, you will be always in the home button, in home tab, and in the home tab on the right side. So we'll be able to see we have this help button. So let us open it. And yeah, it should open. So it's up. So here, so yesterday we covered on Simulink and Simscape, which also involves physical modeling a bit. We did not dive too much here, but yeah, we did little bit touch on some of the aspects. Then now in today's session, we'll be focusing on, so this area, this is the area that we are trying to focus right now. So where we have family of library, we have toolboxes we have, which helps us to focus on implementing AI applications, which also basically involves statistics in the background. So we also have statistical functions readily available, which can be used if you want to use it. So our focus will be AI more in this library. So let us have a look what and all toolboxes are there. If I click on it, it will take you to the toolbox, means the documentation page. And if you scroll down a bit, so here you will be able to see we have 4 number of products which helps you to build AI applications. So one of the application we will be focusing is this statistics and machine learning toolbox. One more toolbox we'll also be focusing in our session is deep learning toolbox. So these are the two toolbox as of now we'll be having a look into, because both machine learning and deep learning both are popular domain applications which are so relevant in EV applications. So we'll try to look into that idea, how to start using our library. We'll do some general application initially, and then we'll also see how these general application workflows ideas that we are learning will be helpful for even EV application also. That is also something we'll understand it. So now So what we will do right now, we will go back to my MATLAB, we'll start over. Now we know the toolbox idea, we have around, so couple of toolboxes are there. In that we'll be focusing on some of the toolboxes in this session, statistics and machine learning toolbox and deep learning toolbox, right? So now, what is the first thing we want to know if you want to start working with AI applications? So we'll start with a script. So which is the script we will focus on? So let me close it. Let me relaunch the script. So you have a button called as, so two options will be there when you are having latest versions of MATLAB. So you'll always have two script options. So in that, so we normally work on second format of script, which is called as live script. So if you launch the live script, now you can see three more additional tabs will be opened up called as live editor, insert, view. Three additional options should come, and in that live editor will be automatically selected, and you should see these options along with this script format. Command window may get minimized. You can completely minimize it yourself. Manually you can drag it down and you can minimize it. We can focus on the script. So now what we will do here, you can see this script version has some additional functionality compared to older script format. So you can see here, if you want to immediately write MATLAB program, you can see code area is already inserted here. So we can start writing MATLAB program, whatever we want to do immediately without any delay. And whatever I want to implement, if I want to execute, I can execute and I can see the output, everything we want, whatever we want to do with respect to program, we can do. But in additional to that, so you can also do some documentation here using this second option called as text. So that is what we'll do now. We'll use the text option. I will add a text. I don't want to immediately write program in my case. I want to do some documentation before I do some application implementation. So I can document those things right now here. So now instead of the programming area, now I have added a text area. So now you can see very quick changes. The gray color area is now cleared up because programming area we have removed it. Now we can also see the serial number, what was there earlier. The serial number is also now invisible because we are not inside a programming area. The serial number will be always tracking only the programming area. It will never track the text area. This is also something we can see. So now what we will do here, so we'll add a title to begin with. I will change the text format. So there are multiple formatting options. By default it will be normal text, you can see that, but it need not be normal text every time. If you need, you can also use other formats as and when you require. We have other options also like headings and title option. I am writing right now for the first line, I want to add a title to my script. So I'm adding a title. So let us do the first important thing. What is the first basic thing we need to know in MATLAB if we want to implement AI application is how to import the data inside MATLAB, because most of the data that we want to work with will be outside MATLAB, maybe an Excel sheet, maybe collection of image files, maybe collection of signal data, whatever it may be. It will be outside the MATLAB in a memory location like this. How to make it available inside MATLAB? So that is the first thing we should know. So that is what we'll quickly focus on. So in the older versions of MATLAB, if you had to focus on importing the data, we had to do manual data import. So this, nowadays we don't do this. If we are using very older version of MATLAB, then only you need this. We do this only in older version of MATLAB. Now also we can do, but we don't do this because this method has its own disadvantage. So we understood this disadvantage, and in latest versions of MATLAB, I think somewhere from 2023 onwards, we got a new way to import the data. So where we can do automatic data import. That is what we will focus on right now, because you also have latest version 2024A, I think, is running in the machines. That also has this capability available. So we can do there also. Automatic data import can be done here also. So this is what we will focus on in this session today. So what I will do here, I will make it bold so that I know this is what we'll be focusing. Older version I don't focus. We can do it. It's not like we cannot do it, but I will show you why it is not required to do. If you are focusing on this, we have an advantage of doing that. So that is what I will show you. For that to do, what I have to do is now, just give me 1 second. I also have to share you the data with which you can work on. For that, let me open MATLAB drive. Yeah, here I should be able to. Okay, again, internet I think is disconnected. Let's see. I think Wi-Fi is disconnected. I don't know. Let's see. But ಇದು ಕನೆಕ್ಟ್ ಆಗ್ತಿಲ್ಲ. ತಗೋತಾ ಇಲ್ಲ, ಕನೆಕ್ಟ್ ಆಗೋವರೆಗೂ ತಗೊಳ್ಳಲ್ಲ ಅದು. ವೈಫೈ ಇಸ್ ನಾಟ್ ಕನೆಕ್ಟೆಡ್, ಮಧ್ಯದಲ್ಲಿ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ. ನಾವು ಈಗೊಂದ್ಸಲಿ ಟ್ರೈ ಮಾಡೋಣ. ನೋ ನೋ ಕೊಡಿ. Key is not proper. Key check ಮಾಡಿ. ಇದಕ್ಕೆ ಮತ್ತೆ ಲಾಗಿನ್ ಆಗ್ಬೇಕಾ? ಲಾಗಿನ್ ನಿಮಿಷ, ಇಲ್ಲಿ ರಿಫ್ರೆಶ್ ಮಾಡೋಣ. ರಿಫ್ರೆಶ್ ಮಾಡಿದ್ರೆ ಕನೆಕ್ಟ್ ಆಗುತ್ತಾ? Okay, I will share it. So it has to load the window. It's taking few seconds, I think. Let's see. Okay, it's loading. It's very slow. Okay. Not this one. Sorry. This folder. So everybody can open this link, online clipboard. I will go back once again to show. Not this one. Online clipboard is not opening. Okay, let's try different one. If that is not working also, I will show you one more way to open it. Let's try different one maybe. Again, okay. We'll try continue, then let's see. Yeah, it's opening. No, it's not opening. I think they have put some. It's opening. Okay, firewall has allowed it. So this is how it will look like. So what I will do in my case is I will put the URL here, and then for it to make it accessible to everyone, I have to send to the clipboard. It will generate a code. Let us wait. It's done. So for everyone, you can see in the website there will be this page called retrieve from online clipboard. In this space, enter this serial number 4624 and hit retrieve. Click on this button. Whatever the serial number is there, enter this serial number in the space, retrieve from clipboard and hit click. You will automatically, your browser will copy this URL automatically. So for you, what you can do is open the new tab, paste the link. So do Control V, it will paste the link automatically and hit enter. It will take you to the preview. In my case, since I have already done my account login, it will not show me the preview here. For me, what I will do is I will open the browser where I don't have login. There I will show you how it will look like. Yeah, here I should be able to show you the same preview. Yeah, it is loading. So it should display like this. ಆಯ್ತು ಓಪನ್ ಮಾಡೋಕ್ಕೆ. ಸೊ ಜಸ್ಟ್ ಇಲ್ಲಿ ಬನ್ನಿ, ಚೆಕ್ ಮಾಡಿ, ಲೆಟ್ಸ್ ಸಿ. ಅಲ್ಲ ಒಂದು ನಿಮಿಷ ಕಾಪಿ ಆಗಿರುತ್ತದು, ಬಟ್ ಇನ್ನೊಂದ್ಸಲಿ ಬೇಕಾದ್ರೆ ಮಾಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಪೇಸ್ಟ್ ಮಾಡಿ, ಹಿಟ್ ಎಂಟರ್. ನಾವು ಇಟ್ ಬಾ. So are you guys able to open this? Access icon. So I think most of you have been able to open this. So what you have to do here, so since we are using offline version of MATLAB, which is installed in our machine, we have to download the data. Click on this link called download shared folder. You can see it will ask you to save the file somewhere. You can choose any location wherever it is suitable. Select the location and save the file. It will start downloading. For me, it is already there, so I will not download it. But for you, you can download it. Maximum it should take is around 2 to 5 minutes, and you should be able to get it downloaded. So it's, you can see the total memory size is around 123. So since you are downloading the zip file, so you should be able to download it quickly. So once you download, what you have to do, I will show you. What you will get a zip file like this. Folder name is data. So here I am showing you for a different folder, but the idea will be same. You will get the folder called data. Let it download. Once the download is complete, from the browser, access the folder. It will open like this. you can access the folder location, and from there, so right click and extract the folder directly. It will extract the folder. So you can open the folder, then on the top you can copy the address path using keyboard. So select the address and copy the address path, whatever it is. And in MATLAB you can set up this location here. If you set up the location, it will take you to that location. You can go inside and access all the contents. So here I'm accessing different content, but the idea is same process you have to do once the zip file is downloaded. Same process you have to do there also. Download ಆಗ್ತಿಲ್ಲ. Okay, I think one window should open up. You have to wait maybe. So normally if you click on it, a window will open up where it will ask you to save the file in a memory location. Save window should open up. Okay. Okay. No worries. So we will wait for 5 minutes. Let it download. If in case it is still downloading, we can continue the work here. Once it is downloaded, you can do the same thing later also. That is not a problem. But you will be able to get the basic idea very clear. So that is something you should be able to confidently understand. That is something we'll, so make sure it is done. Yeah, okay, I think this should be fine. So I will use this folder. So this is slightly different, but we can address the same idea here also for this folder in my case. Yeah, so a window like this should come if you are saving the file. So select the location and download the file. That's it. In the download, sir, I think for yours it is downloaded. Oh, it's still downloading. Okay, 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 okay. Oh, still only 3.9 MB. Oh my god. I think it may not download completely, but still it's okay. ಅಲ್ಲ ಇವಾಗ ಅದನ್ನೆಲ್ಲ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ, ಯಾಕಂದ್ರೆ ನಾವು ಏನೇ ಅಪ್ಲಿಕೇಶನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಎ ಐ ನಲ್ಲಿ ಡೇಟಾ ಇಲ್ಲ ಅಂದ್ರೆ ದರ್ ಇಸ್ ನೋ ಅಪ್ಲಿಕೇಶನ್. ಸೊ ದಟ್ ಇಸ್ ವರ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್. So we'll access the data and then we will move towards machine learning, deep learning. General application will cover right now before the tea break. After tea break, I will also showcase EV application also. So we'll wait for 1 or 2 more minutes before we start. Is it completed? Downloading?
Internet is very slow. Still it is downloading. 8 MB file has downloaded. Just close again like this.
Okay. No, let us not wait that much.
Common sharing file ಇದ್ರೆ ನೋಡಿ ಸರ್.
ಅಂದ್ರೆ ಇದೇ ಮೆಥಡ್ ಇರೋದು, ನೀವು ಡೌನ್ಲೋಡ್ ಮಾಡಿದ್ರೆ ಆಫ್ಲೈನ್ ಅಲ್ಲಿ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ನಿಮ್ಗೆ ಆನ್ಲೈನ್ ಆಕ್ಸೆಸ್ ಬೇಕಾಗುತ್ತೆ, ಎಲ್ರಿಗೂ ಆನ್ಲೈನ್ ಆಕ್ಸೆಸ್ ಇಲ್ಲ. ಸೊ ದಟ್ ಇಸ್ ಪ್ರಾಬ್ಲಮ್. ನಂಗಿದೆ ಬಟ್ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ಗೆ ಇಲ್ಲ. ಲ್ಯಾನ್ ಥ್ರೂ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಆನ್ಲೈನ್ ಅಲ್ಲಿ ಇರೋದು ಡೇಟಾ, ಕ್ಲೌಡ್ ಅಲ್ಲಿ ಇರೋದು ಇದು. ಹಾ,
Possible to copy.
ಹಾ, ಕ್ಲೌಡ್ ಅಲ್ಲಿ ಇರೋದು ಡೇಟಾ ಅದು.
You have the copy sir?
ಇಲ್ಲ.
Cloud.
ಹಾ, ದಟ್ ಈಸ್ ದ ಥಿಂಗ್.
Otherwise in one system we can download it, then also not problem.
ಅದು ನಿಮ್ಗೆ ಇಲ್ಲಿ ಭಾಳ ಸ್ಲೋ ಇದೆ, ಇಲ್ಲಿ ಆಗಲ್ಲ ಅದು. ನಿಮ್ಗೆ 2 hours ತೋರಿಸ್ತಾ ಇದೆ ಟೈಮಿಂಗ್ಸ್, ಆಗಲ್ಲ ಅದು. 120 MB ಫೈಲ್ ಅದು,
120 MB.
2 hours ತೋರಿಸ್ತಾ ಇದೆ ಅದು. In AI applications, you work with GB of data. So right now, let's solve it. So let us not delay. So I think it is taking time to download the file. No worries. I will share this. This data is in my cloud, so I can share this data later also. But right now, let us not waste too much time. Let us understand if we have access to data like this. So how we can import the data in MATLAB? Let us have a understanding. So now how shall we start? So now we are multiple types of data are available in my folder. You can see I have a couple of Excel sheet data, CSV data. I have image files like this in the folder. So you can see, so I have a couple of image files here. There is one image file here. So I have, this is the folder where I have kept different, you can see Excel sheet also again here. So I have different formats of file available in this folder. So no matter whatever the type of file we have, and our idea is now how we can import the data and make it available inside the MATLAB. Right now, all these data are present in my memory location, in my hard disk, but it is not available inside the MATLAB. So we have to make it accessible to MATLAB. So how we will do that? So the first idea is for that, so we will add a programming area. So the difference in manual method and automatic method is, in manual method, I need to know that, let's say if this is the Excel sheet I am interested to import, what is the inbuilt function that is available in MATLAB which helps me to import this format of data? We should know. If we remember the inbuilt function, then I can manually write the program. I can import the data very easily. But the problem is, for different formats of data, like for Excel sheet, we have a different function. For images, we have a different function. So for different files, we have different inbuilt functions in MATLAB. So what we have done right now is, we don't need users to remember any of this inbuilt function, not required. we can do automatic data import. That means no matter whatever the data you have, you should be able to import it without any headache. That is the idea here. So how we do that? So if you remember yesterday we talked about apps, right? So where we have GUI interfaces. The problem in app is whatever app you will open here, if you remember yesterday, a pop-up window will come, GUI will pop up, and we have to work with the app separately. So what we started to work in live editor is, can we integrate those kind of apps inside a script? That is what we started. And now we have started to create something called as tasks. This is available in live script format. You can see we have extended capabilities of a script where we have created multiple amounts of GUI interface like this, and in that you can see we have a dedicated app GUI interface we have created. We call this as task. That means the reason why is this is an app interface that I can keep it inside a MATLAB script. That is the idea. So I can add it now. I can add this import data GUI. You can see it is now adding inside the programming area. So let me expand this so that you can see complete interface. I'll change the view so that you can see that it should look like this. Yeah. So this is how the app interface will look like. This is how the import data GUI looks like. Now you can see you can import data from a file. If you have a physical file available in a memory, you can access this using the browse button, select the file. App will take care of importing the data automatically. So that is why we call this as automatic data import. I don't need to remember any inbuilt function. I can directly click. You can see all the files are available. Whichever file you are interested to maybe test or train. So this is a testing data set. This is a training data set. So let's say I want to start by loading a training data set. You can easily select it and you can see it is doing the work in the background. Once the execution is done, your work will be done automatically. It will import that Excel sheet data. You can see the Excel sheet data. It is now available inside MATLAB. The variable name it has created is called as train, and you can see that in the workspace also. Yes, now it is now inside the MATLAB. That data, whatever we had outside, now it is inside MATLAB. We can see that very easily. So here also it will give you feedback that whatever the type of file you are importing, it is a table data. So in MATLAB also it has imported as a table data itself. So MATLAB is only taking care of importing the data by itself. I don't need to remember any inbuilt function. So this is something you should be able to, if you have downloaded, you should be able to see this. If not, also later also if you do this, same thing will be appearing you, because that is how my table is. Let us verify myself only. So if I open this outside MATLAB also, you can check it in the Excel sheet. It will show you the complete data. So here also you can check it yourself. So let us see how many number of rows we have. So you can see 892 number 8. So from 0 it is counting. So we have total 891. 0 to 892 is 891. So then we can see the total number of rows. So A, B, C, D, E, F, G, H, I, J, K, L. Total 12 number of columns. So same size also you can see here also. We have 891 number of rows and 12 number of columns. Same Excel sheet is now inside MATLAB without any headache. So now some of you may ask question that this is okay, but what is actually happening inside the MATLAB to do this? So that is also something we can identify it. What is MATLAB doing here to basically do this job? We can identify it ourselves. How you can do is, if you want to just see how MATLAB is doing the job, just expand this option called as show code, and MATLAB will show you the inbuilt function that it is running. You can see. You can ignore this pre-processing. Not every time you have to do this. This is just optional case. That is why it is called as options, not compulsory, that you can ignore. If you don't do any options also like this, you can also import any table data you have, Excel sheet, CSV. So any table data you have, you should be able to import directly. So if you had to manually write the program, this is the inbuilt function you had to use. You had to remember this. Then you had to remember the syntax of the inbuilt function. Then you should have you will be able to write the program. So that is how you do. But in MATLAB, not compulsory. MATLAB, if you use the data import app, it looks into the format of the data, and based on that, MATLAB will only identify the inbuilt function automatically. So I don't need to do this. That is how MATLAB works. Now, how I can use this program in future. So we can do that. So what we can do right now is, so whenever you are using a app task, from the task, if you are inserting any interface like this in MATLAB script, you will be able to see there will be multiple number of options in all those GUI environment. You can click on the options, you will get these standard options like this. If you click on that options, you should get this. In that, what I will do now, I will tell to MATLAB, whatever you have done, give me the program. I don't need the GUI now. Convert that GUI as a program. That is what I will tell. What it will do, if I click it, GUI will be cleared up. Instead of the GUI, I will, whatever the program I was able to see, now I can keep the program and I can use it in any number of scripts. So now I have a ready-made program and I can do the job. Now if you, so I can verify it now. All these options not compulsory to keep it. This is just additional settings it is doing, but not necessary. I can remove this. I can customize it. Now I can create my own program very easily. Now I have a ready-made template. So this is the program. So now I can remove this also. So if you start with double quotes, end with double quotes only. So now this will do the job. OPTS, this is also not required now. We have removed the OPTS variable. We are focusing on importing the data, displaying the data. It will do the job. You can see that. So now we have a ready-made program. So that is the advantage. Either you can use the older function, whatever was there earlier, you can use that also, it will work. Or you can create your own program very, very quickly using the template. So like what we did here. So this is how you work with MATLAB. You take the GUI interface, generate the program, and then if you want to customize it, like how you have seen here, you can quickly, within few seconds, you can customize the program and make it suitable for your application very, very easily. So this is how MATLAB we do. Nowadays, we don't go for old version manual writing of program. We so avoid doing it because it saves the time. As you can see here, it saves the time. So work with the GUI interface, select the data, it will do the job, convert it into program. And if you want to edit, keep it as it is, you can keep it as it is, or if you want to edit the program little bit, you can do editing and you can start using the program very, very easily. So this is how we basically work. So now, since most of you doesn't have these external data, right now for machine learning, deep learning, what we'll do, so right now we know how we can import external data. So this is something we wanted to start. So this is how we do work in latest versions of MATLAB. So I will keep this file script, I will save it so that we will continue with the next application. So I will save it as data import. Yeah. So now we can focus on the next application idea. So in this application idea, what we want to do here, so again we'll add a text and a title to begin with. So let's say I want to see how I want to implement machine learning application. It can be, so I have been able to get information from coordinators that already multiple, so theory sessions has already happened. So you will get an idea what is machine learning. I will not cover the theoretical part here. So what if I want to implement a machine learning model? It can be classification model or even if required. So in many EV application, we may also require to implement regression model also based on the application what we are doing. It can be either classification model or a regression model. So how we can start implementing applications? So first and foremost, we need to have a data set. So that is the first step we will do. So we'll add the heading here. The very first step we have to focus is, so we have to load the data set. Without the data, so there is no data driven applications. So that is the first process we will do. So if you have a external data, now we know how to do that, but that is not we will do right now because many of you don't have that downloaded folder. So but you have access to statistics and machine learning toolbox. So what we'll do right now is we'll load couple of library. If I want to work on classification or regression, let us take maybe regression application. Maybe we'll take a data set which is available in statistics and machine learning toolbox. It is called as CARBIG. So we'll load the data, and what we'll also do right now is, so a variable which this data is we are not using right now, so we don't want this data right now. So before we load the actual data that is required, we'll also clear the MATLAB workspace using this function, and then we will load this data. And if you do, you can see that table variable will be cleared, it will be deleted, and fresh set of variables should automatically load because you have statistics and machine learning toolbox in the MATLAB. So if you do this variable will be automatically available. So right now we are focusing on regression application here. So whatever you are loading, you can see it will load up in the workspace. You should get all these variables. It will automatically happen. You can see it will have 406 number of data samples everywhere. If anybody is unable to do this, let me know. Anything, .mat is optional, not compulsory. Even if you write .mat also, it same thing should happen. So I hope everybody has been able to do this. So now what is next? So right now the way we have, means the team of people who have arranged this data, you can see all each and every individual feature data whatever we have here is available separately in each and every different variable inside MATLAB. So what we will do right now is we will do step number 2 where we have to do simple adjustment of this. So that is what we'll do in. So what I've done, again I have skipped one part, right away I have done. So what I'm doing here, so in your new version of script, you can divide the scripts into different sections. You can see here we have a section area where you can create different number of sections. So I'm doing a, after this line, I want to separate it with a new section. If I want to, whenever I want to do this, you can see, you can click on this button, section break, and you can see it will break up, and a fresh independent programming section is now available here. I can use it. I can continue my job separately here. So here you can see again same coding area, text area, everything you can access. So in this section also we'll add a heading where we'll do step number 2 where we are focusing on tabulating the data. We will tabulate the features and response. We have one output response which we are interested to predict. and remaining feature data is also there. We have features also directly available. You can see that we have multiple features. So everything we will tabulate it in one single variable so that it is easy for us to work. That is what we will do. So there is a execution bar here if you want to run. So you can see here for every section there will be an execution bar. Click on it, it will execute the command. Any number of times you want to do, you can execute it, it will work. So for every section you will get independent execution bar like this on the left side. You can see here execution bar will be there. Whatever program you will write, you can execute the program here directly. Every section you can independently execute. If you want to execute everything together, then this button will be helpful. If you want to independently execute each and every section, use this execution bar. So now what we will do here to tabulate, so we will create a variable called data set. We will load everything in one variable. We will call that as data set. And to tabulate everything, I will use a inbuilt function called table. It's a part of inbuilt function in MATLAB. So what and all variables I want to integrate. So the only output data in this whole data which I want to predict is MPG, which is called as miles per gallon. It is a mileage data. So we have a car information for around 406 vehicles here. We can see everywhere the sample size is 406. We have car vehicle data information, especially on car. We have around 406 different vehicle information, like what is the acceleration, so how many number of cylinders are present in that vehicle, what is the displacement performance, what is the horsepower performance. So we have performance data of vehicles, which will be the features, and based on these features we want to predict what is the mileage of that vehicle. So we have the data information on that. As column I will keep all the maybe horsepower data. In the third column maybe I will keep all the displacement data. Then let's see, any other variable shall we consider? Yeah, so we'll also consider origin is a character data. So you can see which gives you information in which country that particular vehicle has been manufactured. So what is the model year of the vehicle? That is also something we will capture. What is the weight of the vehicle? Because weight is also an important parameter we have to consider. So your choice. So you can keep it. Now the final variable which I will keep is the output response. The data which I want to predict from all these input variables are my miles per gallon. So I will keep it at the last column. I will make this as my final column. Remaining all are my input features. So we have 1, 2, 3, 4, 5, 6 number of features. I am considering it as input features. And this is the final column which I am interested to predict using a machine learning model. So now I can execute this program. It will create the table automatically. So now we have the data set ready. So this is the overall program we have written. I hope this is done. Aita? Okay, now what we have to do? Now we have the complete data set. Normally in either machine learning or in deep learning, we don't use the complete data set directly. We divide the data set or we partition the data set for training and testing. So here also we have to do that. We have to divide the data set into two parts for training and testing. So we'll do that. So for that we will again do a section break. Whatever we wanted to do in this section, it is done. So we'll stop working on this section. We'll start working on a fresh section. So in this section, we will now do partition of the data. Whatever the data we have, now I want to partition the data into two parts. We can do more than two also. Validation data set also we can do. But right now, I'm not interested in doing that. So we'll go for only two parts as of now: training data set and testing data set. So we'll divide this data set into two parts. So now to do this partition, what we have to do, first thing we have to do is how many number of data points we have in our data collection. That number value we can see here, but that should be available inside workspace. So that is what we will do right now. We will extract the data value. So I will store that in a variable called n for me to simplify. And I can extract this information by very easy. There are many different inbuilt functions that are available. So in MATLAB to do this. So right now I will make use of an inbuilt function called size, and I will tell give me the size of the data set, but don't give me both the size. I know if I use this, I will get the number of rows and number of columns, both the size information I will get. I'm not interested in that. I need only the first size information, which is the number of row. So to tell that to MATLAB, I will use the dimension component, and I will tell give me the first size dimension. I'm not interested in the second dimension. Don't give me that. Ignore the second dimension. Give me only the first dimension. And if you see, you will get the output. So the dimension is now ready. Now using this information, I can easily create a partition without any delay. Now since I have the information about how many number of data points are there in my data set, I can use this information and I can create a partition. So this one stands for the dimension number. You can see in MATLAB always your minimum dimensions will be always 2. So in that I am accessing the first value. So now using this information, since I'm working with machine learning application right now, we can use inbuilt function that is available in MATLAB. So machine learning library through which I can create partition. So this is the partition function I will use. This is part of machine learning toolbox library. It is called as CV partition. So first information, you can see it needs number of data points. So n is already created, we will use it. And then it will ask, so by default you can see the validation scheme is already inbuilt. By default in this method will be always cross validation, but if required you can change the method. In our case we are not focused on so cross validation here, so we'll change the method here. So we will go for a method called holdout partition scheme we will use here. So we can open the double quote, type this keyword holdout, H is capital, O is capital, you can see that. So now it will ask me, since we are going for holdout partition, so now it is asking me, so how much percentage of data so you want to hold out. That means, so we will always hold out the data for second partition every time. So it is asking me for testing data set, how much percentage of data you want to hold out separately from the data set. So let us do maybe 70%, 30% partition. In that case I will tell I need to do so 30% partition, maybe I will use 0.3 to represent 30% partition. So physically the partition available now, if you want to do with 406 number of data points, if you have to do 30%, you have to keep it for testing data set. So minimum at least 121 data points should be in the testing data set, and remaining 285 data points should be present in the testing data set. So it is giving us the scheme. Now we can use this scheme and we can do the partition very, very quickly right now. So that is what we will do. So what is the first step? The first step is, so we'll start with creating training data set. And to create the training data set, we have to access the index from this partition. So one thing we have not done, which is very bad. So we have not saved this partition. So I will create a variable called CVP. We will save the partition in a variable. I will ignore this program right now. We'll execute this once again. Yeah. Now it is saved in a variable, which is very good. So now I can do the partition. So now we can do the partition. So we'll start with training data set partition here. So I will also write that in the comment line. We are writing on, so training, we are right now focusing on training data set partition. So first step is this. So every time you want to extract a partition, first step is extract the index values from the partition. So let us see how to do that. So right now, since we are focusing on train, so here you can see there is a inbuilt function. So this is the inbuilt function. You can see whenever you have created a CV partition, from the CV partition you can access the training data set indices, whatever number of values you are taking. For those data values, we have the indexes available inside only here. To extract it, we have to use this inbuilt function. We are using it. So automatically MATLAB can see the only CV partition we have is this. There is no other partition data in my workspace. So it is automatically identifying it. Select it. And it will extract the index data. It will be 406 number of rows, but with binary information. So wherever you have one, these are the selected data from the 406. So we will have 285 number of ones that will be selected for testing, training right now, not testing, sorry, training. Wherever we have 0, those are the training data set that we can extract in the second partition. So right now we are extracting testing data points. sorry, training data points. So now we can extract training data. So very easy now. Where is my original data set? Here. So here I can tell in my original data set. So I don't want all the rows. So I will use training index as the row index. You can see that. But for column index, which is variable, I will put colon, because all the columns are important for us. Input, features, output, response, everything is important for us. So for column we will put colon, but for row we will input this index for extracting those data points. So right now, as per our scheme here, if I do this correctly, I should get 285 data points extracted from the table, original table. Let us see how, whether we can do that. Now if I execute, you can see yes. So now we have a training data where you have, as per the scheme we have created, we have exactly 285 data points with all the columns. Now we know the idea. So same idea I can apply for testing data set partition also. So what we will do right now, we will not waste the time. We will copy paste the code area, coding section, this here only, we will copy paste it. So right now we are focusing on testing data partition. So here we will call it as test IDX, and inbuilt function also we can use it at test. So you can see. So again, this is an inbuilt function we are using. Any cross validation partition is there. We can access testing data set index using this inbuilt function. We are using it. That is one more change we have done. And here also we can change this data also. Now training data is already done. Now we are doing testing data extraction. So same code section we have copy pasted, and we have done modification here, here, and here. That's it. One more thing also, this also we have to modify. Now the input for the second line will be this index, not the first index. So that is also one more change we have to do. So this should be now here. That's it. If you do this, now programming is ready. As per our scheme, how many data points we should get? Let us verify it before only. As per our scheme, we should get 121 number of data points. So let us see whether we are able to get it. And you can see, yes, we have been able to get the 121 number of data points. Now you can see this in the workspace also. This is our training data set. This is our testing data set. So where is the original data set? It will be available in the top. This is my original data set. So from this we have extracted both the data set. We have done the partition. We have the partitions available. This is testing data set. This is training data set. I hope everybody is done until here. Not done? None. Okay. Now I will stop programming at this point. I will not go further with programming because these are the basic processing we had to do. We had to load the data set. We had to divide the data set. Everything is ready. We have the testing partition ready, training partition ready. Everything is ready now. So what we will do right now, when you want to implement either machine learning or means classification or regression based applications using our machine learning library. So if you want to manually program further, you can do it. One way I can help you is, so if you want to programmatically access, I will do some section break. I will not give a title right now, I will give title later. But if you want to access regression models, you can use the keyword fit R, and you can see all our regression machine learning models will appear in a list. You can manually select your own machine learning model and you can manually train here. But normally in practical applications, we rarely do this. We select series of models at a time, we train them together, we'll compare the results. So we will do that right now. To do that, I don't recommend doing programming. So we have a much more better way to do that in MATLAB. That is what we'll as it is right now. What before I do that, once again, what about classification models? Same idea. Fit is the starting keyword. Then you need to add C. If you add C, all the classification models will be accessible. So that is the idea. If you add R, regression models will be accessible. If you add C, all the classification models, machine learning models will be accessible to you. You can access it, you can use it however you want. So that is the whole idea. Now I will not use the programming now. So what we will do, again yesterday how we did, we will go for apps. We will now move to apps. So we'll expand the app area, and right now we'll focus on this area called machine learning and deep learning. On the top we can see that this area, this is the section we'll focus on, machine learning and deep learning. So are we working on classification right now? No. So classification learner we will not use right now. We are working on regression application right now, because miles per gallon is a number information. It can be any number. So there is no any limit to the, so we have a, so real number data that we want to predict. So it falls under regression category. So or regression problem case. So we'll use regression learner in our machine learning toolbox right now. We have this regression learner. So what is the advantage of working with this app? If you work with one app, you can easily learn how to work with other app also, because the workflow, interface, working, everything is one and the same. So let us work with regression learner right now. We'll launch the app. We'll click on that and we'll wait for it. And you can see it is available. I will keep it maximized. I hope everybody is able to open this. Check it once. If you are unable to open, let me know. The app you have to open is regression learner, where it is available in the apps. So go to machine learning and deep learning, and here you can easily access the app. Just click on it, wait for a few seconds. A pop-up window will come up. Double click on the top, it will maximize like this. It will be minimized earlier like this. Just double click, it will maximize. Right now, is it? So when shall we come back? Okay, okay. Okay, I think tea break has been announced. So we'll come back and we'll see after the tea break. we can start. So now what we have to do here now, you can see this app now. What we have done before this app, so we have done some couple of things. We have loaded a internal data set that is available inside MATLAB, especially from our machine learning toolbox. We have loaded a data set. So our data set had input features and output response separately. So we have combined everything and we have created a data set. So as a table, and then what we did, we divided this table data into two separate tables, one as a training data set and then testing data set. So we did a partition. Based on the partition, we were able to extract the data set. So now this is done. It is readily available in our workspace. That means now I can now start interacting with my app. Here we can come back to app. So what is the starting point? We have to start the session. So where the data is available, based on that you can choose any one of the option. Right now all the data points whatever we have is inside the MATLAB workspace only as of now. So we'll start the session from workspace, and now you can see a window will come up like this. So where we have to select the data. So right now what we have done, we have done the partition. So we will not select the original data set because we have manually done the partition here. You can see that. So right now we will start with training data set. That will be the input. And as a thumb rule, always what will your app will do, the final column will be automatically selected as output. That is how app works. And since we have arranged in the same manner, luckily for us also it is same. But sometimes the original table which you extract from other local websites, maybe they will arrange table in a different way. Maybe fifth column is the output response. In those cases what you can do, you can manually so configure it yourself. If wrongly final column is not your output column, then you can manually correct it yourself like this also. So that is also possible. So right now for me I don't need to do that because we have arranged the data in such a way that for our app it is ready. So now do we have to do partition here? No, because we are not taking the original data set. We have already done this partition using program itself. So we'll ignore this part, but we have not set up the validation scheme. So we'll set up the validation scheme here. So by default, as we had seen in the CV partition function also, here also you can see the common, or by I can say default validation scheme every time will be always cross validation. If you don't want it, you can also go for different. We have already run holdout validation for partition. We will not use that right now. So maybe if you want, you can also go for resubstitution validation. So if you don't know what is the idea, how the algorithm works, you can see documentation is available here. You can open the documentation. You can have a look and understanding later also. Right now I think our Wi-Fi is disconnected here, but for you, if the Wi-Fi is connected, it will take you to the documentation. You should be able to read the information. So right now we will keep the cross validation only as the validation scheme, and then by default the k value for cross validation scheme will be always 5-fold cross validation. For our data set right now, so 5-fold cross validation is more than enough. It's a small data set, so it's okay. But if you have a large data set, then you may also increase the number of folds to effectively implement this algorithm. That is also totally fine. So that is the idea. Now start the session. Everything is ready. We'll start the session. So first thing what you will do, you will get the data visualization immediately. You can do data visualization, you can do analysis before you implement your machine learning or applications here. So let's compare. So maybe I will observe the acceleration information. So here we can see this is the graph we have got. So you can see our x-axis plotting all the acceleration with respect to my output variable, which is miles per gallon. So here we can see we have maximum amount of variable giving us maximum mileage, which is falling under somewhere between 16 so units of acceleration to 18 units of acceleration. Somewhere in the middle we can see we have vehicles which are giving us maximum amount of acceleration. There are certain outliers, we can ignore those outliers right now. If you look into major cluster, here we can see we have one of the major cluster which is giving us maximum acceleration performance. It is falling somewhere between 16 to 18, here you can see that range. So we can also broadly consider it as 14 to 18 also, totally fine. So this is the region we are focusing on. That is one information we have got. Let's see maybe horsepower. Horsepower has a different kind of relation with respect to output. So horsepower is telling if your horsepower is less, better the mileage performance. If your horsepower is greater, lower the mileage performance. We have an inverse relationship here. Let's see displacement. So displacement also has similar relation, inverse relation. If your displacement performance is lower, better the mileage. If your displacement performance is higher, so you can see the mileage performance is on a lower level. So majority of the cluster we have on a lower level. There are certain outliers. Right now we are focusing not on the outliers, we are focusing on the clusters. So if you observe those cluster, we can easily identify what is the trend of the data we have. So we have inverse trend for our input versus output. So this is something you can analyze yourself. That is what your app will help you to do. You can analyze the data if it is required to do. Then once you are happy with all the analysis, now you can go for selecting the machine learning models. All the machine learning models will be available here in this section called models. Right now, since we are using regression learner, only the regression models will be available here. Classification models will not be available here because we are working on a regression application right now. That is the idea. So let us see. If you expand here, you can see all the standard algorithms will be available, starting from linear regression, classification, not classification, sorry, regression tree. This is a regression model, sorry. So then support vector machine models, efficient linear regression model, Gaussian regression model, then kernel approximation method where you will get so all the kernel based algorithms, then ensemble models. And if you have installed deep learning toolbox, then you will also get some of the basic neural networks also. You can also see in the final section, if you have deep learning toolbox installed, then some of the basic, not advanced neural network models, some of the basic neural network models will also be accessible here only. That is also possible. It depends. If deep learning is there, then this section will be visible. If deep learning toolbox is not installed, then this section will not be visible. That is the idea. So if you want to manually access the toolbox, if you know the theory behind those model, if you know the idea behind those model, then you may have some good idea based on the data analysis, and so you have done, you may try to use some of the models based on your idea. In that case, you can manually come here and select those specific models one by one and put it into the list here. This is a model list, we can see one by one you can add those model into the list. That is one way. Let's say we don't have the theoretical idea, then also you can see we have a section on the top here which helps you to select so model based on your criteria. If you are like, I don't have any limitation, I want whatever models are available here, every model I want to train, if you are want to do that, you can see you can choose this option which will select every available model and it will train every model. We can train everything, every model at once. This is one option. Or if you are going for hardware integration where we do code generation in Simulink, you can see we have code generation supported. Not every model is code generation supported, we can see. So we can choose only those specific models which are suitable for code generation so that we can do hardware integration. So that is also something. So we can, if this is the purpose, then you have to choose this. Or if your purpose is right now, I don't worry, right now my focus is I want to train the models very quick, I don't want to waste the time in training. If that is the case, we can choose this option also. It will select only those specific models from the available model which MATLAB thinks it can train very fast. So it will select those models so that we can quickly complete the training process without wasting too much time. All the options are there. In our case, we will choose this option right now because I want to show you the application process as quickly as possible. So I will choose this option right now. And you can see every time your regression tree or classification tree model will be added in the app by default. You can keep it if you want, or you can delete it if you don't want. In my case, I don't want it. I will delete it. I will keep only my selection where I have chosen multiple models, where it will add multiple models which are very, very fast to train. That is my criteria. Based on that, it will add the models. Now to add these models, we will start the training here. You can see there is a train button. We'll click on the train button and the training process will start. So you can also see, so now it is starting to load the, in this you can see, yeah, it is loaded. All the models are loaded. So for my case, 6 number of regression models are loaded, and you can see it's almost done. It's completed in my case. Training is done. So right now, since we have done the training, you can see the final results. In the same response plot, the results have updated. Now you can see the graph legend window also has updated. It is not only showing the data points, it is also showing the predicted data points. And if required, if you want to also observe the deviation, that is the error, you can also activate this and you can observe the deviation also. So you can see it will show map your predicted data point with its corresponding actual data point so that you can observe the deviation, which will end up in your RMSE value. If you calculate the deviation and if you calculate root mean square value for all these in summation, you should get the final RMSE value for all the models, and you can see that here. So the idea is very simple. If your RMSE value is very, very bigger, so for this also let us plot the response. So now you can see by default always this plot will be for the first model. For the remaining models, it will only show the model metadata. It will not show any plot. For any model, if I want to see the plot also, whichever model you want to see, you have to manually plot the response plot here. We will do that here for final model. And here also, if I see the error, you can see the deviation is very, very large. That is why we are getting bigger RMSE value. Means the error value is more in this model. Why? We can see this in the graph. We can see the deviation. It's very large. So we have so much deviation from the expected value. So with respect to expected value, if you look into predicted value, the gap or the deviation is very large. So if the gaps are large, then RMSE value will also become big. If the RMSE value is very less, that means the gap is very small. The error is very negligible. So that is what we expect in regression models. The error value should be as less as possible. The predicted value should be very closer or almost equal to the expected value. But even if you have error, it should be very negligible. That is the idea. So now among the selection we can see, so this is the model. So if you see the summary, so this is the model we have trained, and we can also see the hyperparameters of that model. So this is the model right now which has the lowest error rate among the selection, among the models, and you can see it will highlight also that this is the model right now which is having highest error, means highest accuracy, which results in lowest error rate RMSE value. So now what we can do further, we can do couple of things. One thing we can do right now is, if you are happy with this RMSE value, you can directly go for exporting the machine learning model outside the app, so that we can use it in either MATLAB, Simulink, anywhere we want to use. We can focus on using it. That is one way. Or if you are still not happy with this result, we can check whether this model means this algorithm, whatever machine learning algorithm we are using right now, is supported with optimization. We can check that. So this is a regression tree algorithm. Let us check it. So here we have regression tree algorithm. So this is the model, medium tree, you can see. So this is the model which has given us the lowest RMSE value, but we can see this algorithm supports optimization. We have a optimizable model available. So whichever algorithm will have a optimizable model of the same algorithm, that means the algorithm supports hyperparameter optimization. You can see there are certain algorithms like here which doesn't have any optimizable model, because the mathematical model doesn't supports tuning of the hyperparameters. So it is not tunable, means you cannot do hyperparameter optimization. But you can see majority of the algorithms whatever we use will support optimization. So in my case, I can add this optimizable model as a final model here, and I can try to optimize the hyperparameters. You can see here. So for classification tree, minimum leaf size is the only tunable parameter we can go for. Either you can keep the surrogate data as so on or off. You can tell find all. This is fixed values we have. We don't have much values to tune with. So you have to manually set up the value for this parameter. But for this parameter, you can see you can connect to the optimizer which we have here, and we can use our hyperparameter optimizer to optimize this parameter for reducing the error as much as possible. It will try to minimize the error as much as possible. So that is what your optimizer will do. It will go for minimizing the error. So now either you can set up the optimizers options here, or you can set up the same optimizer options here also. Anywhere you access, you should get this interface like this, and you should be able to set up the optimizer options before we start the optimization. So we have standard algorithms which we use in optimization, Bayesian optimization or grid search, random search algorithm. So all those standard algorithms are readily available. By default, always you can see Bayesian optimization is the solver that will be automatically selected every time. But if you want, you can change the solver, the algorithm solver also if required. That is totally fine. So next, which we do is, so here only, what is the objective function? So acquisition function here is nothing but our objective function. What is the end result we want to generate? So here we can see default will be always this. As the time passes, so we are expecting the model to improve the result. That means we are to minimize the error as much as possible. So that is what is our idea. So that is the default optimization objective function always. So now for running this algorithm, how many number of iterations you want to select? You can control this. Default fixed number of times will be always 30, but if you want to increase it, you can do it. Maybe you can run it for 50 number of times, 100 number of times also. But if you don't do adjustment, always the number of times will iteration number will be always 30 fixed. Maybe in my case, I will go for 50 number. I will try to increase it to 50. We can do it. Then again, like how we did here, if your training time is also very important, you can also set some limits for your training time also. Like you can tell you do the optimization up to maximum of 300 seconds, that is 5 minutes. Within this time, if optimization is whatever is done, take the best hyperparameter within that time. If you want to keep a limit, you can give it. In my case, I don't have any I don't want to keep any limit. I will deactivate it. I want all the 50 iterations to complete. So in my case, I will not keep the limit, but if required, you can also keep it. You can see that it is available. So now we can start the optimization. Again, the same train button what we have. If we start the training for this optimization, optimizable model, so it will start the optimization. So you can see it will generate the plot. Yeah, it is starting. So it will try to minimize the MSC, that is nothing but our mean square error, RMSC value. It will try to minimize as much as possible. And you can see it is trying to minimize every time. So in my case it is done. So you can see this is the lowest minimization we have been able to achieve. And by using this, we can see compared to this model, we have been able to get much more lower RMSE value. We have much more improved result available. Let us plot the response plot. Response plot is already generated. We can see that. You can see also see the deviation. So now this is much more better model for me compared to all the models. So one thing we have to keep it in optimization is a tuning algorithm. So the tuning can go good also, tuning can go bad also, anything can happen. So we have to be open with tuning algorithm. If it is able to give us good results, very good. If we are unable to get good results here, we don't have to worry too much. We can try to use other methods. We can maybe our data set is not only sufficient enough to bring the results, or maybe the kind of features we are extracting from our raw data set may not be good enough. So we have to analyze that. We have to go back one step back, and we have to look into those aspects also. So not every time optimizer is the only solution available, but yes, some of the cases optimizer, as we can see here, will give us good results. If everything is proper, it should be able to give us good results than what we are getting from fixed algorithm. So fixed hyperparameter models compared to that. So tunable model should give us good results, but sometime it may not give also. So we should be open to that. So now luckily for us, we have got good result. That means now if I can ignore everything else, now maybe I can use this as my application. So now what we can do here, couple of options are there. So the option which I normally use is this function. What I will do right now, if I had to write a program myself for implementing this machine learning model, what is the program that will be required to generate? I will automatically generate a MATLAB script using this function. So I will click on this, and you can see automatically MATLAB script will get generated. And where is the machine learning implementation? We have to scroll down a bit, and you should see a title. I will show you that. Yeah, so here you can see, whenever you are able to see train a model, any model it can be, because you will use different algorithms, the algorithm name will change. But you can see whenever you see this function, that you can see this is the code you had. If you had to manually write the program, this is the program you had to manually write. You can automatically generate the code. Now I can copy this, I can paste it in my script here now. So I have the model ready. So I can, from this training data set, if I extract the input features which are predictors, and if I extract the output features, and if I pass it here, now I can train the model here also. Any data set now, any data set I can train here. I have a template ready. Not only this data set, now I have a template using which I can train any data set I have at hand. So that is what we can simplify. So let's try to do that here also. Let us take the training data set and let us try to extract predictors. So I will copy the variable here, and I will create the variable here also. Let us load the predictors. Predictors are nothing but input features. So in our table, except final column, remaining every column data is input features. So I have to keep it all those data from my training data set here. So for that, I will access the training data, and I will tell all the rows are important, but in columns, from first column till last but one column, all those are input columns. So in MATLAB, we can use end as a index, end with final index. So by default, so we are using end -1 to ignore the final column, because that is the output response. Then similarly, I can also extract response. If we get any error, we don't need to worry. Sometimes while I do this, some minor error may come up. We can debug that very easily. It's not too much headache. We'll see that. So training data. Again, all the rows are important, but output response is final column. So I will use end to access the final column. So right now I will ignore this program. I don't want to immediately train. So I will comment all these lines. So I'll select all the lines, and on the top here I can use the percentage button to add comment line to everything once. Now let us run these two programs. Let us check whether this program is correct. If sometimes we may get error, minor syntax error I may do, but we'll debug it. If everything is correct, everything will happen. Otherwise, we'll debug the error. Then only we'll go for training the machine learning model. Okay. Luckily for us, there is no error. Very good. So we have written everything is perfect. So we can see. So 121 data points. We have the data points. So all the columns are available. So not testing data, predictors. So let's check the predictors. Where is predictors? This line. Why? It is there. 285 cross 6. Here also we can check it. So we have a total of 7 columns in our data set. But out of that we can see here also predictors. So except final column, all the initial 6 input features are stored in the predictors, and the final column of the same data collection we have here. So response. So we have both the data. Now I can remove the comment line for this program. I can train this machine learning model. So again, the next button to the percentage, this will uncomment the lines. Wherever you have multiple comment lines, you can remove the comment lines using this button. Now I can train the machine learning model. It will train. Since I have put semicolon, we cannot see the output. But here I will remove the semicolon so that we can see the output. So here we can see once the training is done, you should be able to see. If you remove the semicolon, it will display the output of that program. So it should show you like this. So these are the input features with which I have trained. This is the output. So parameter in my table. So it will be able to show you all those information right away. And here also in the workspace also you can see this is the trained machine learning model that is available right now. So this is what we have done right now. In this section we have trained a regression model. Now let us do testing also now. I can do the testing in app also if required. You can see there is also a testing section available here, but in my case I will do in the script only right now. Only, right? Sorry. So we'll perform testing of the trained model. So we can do testing because we already have the testing data set readily available. So we can perform testing very quickly. So the output we will get is couple of predictions based on how many number of data points we have. We should get equal number of predictions. So mileage data, miles per gallon data will be predicted by the model. So let us collect all the prediction values in this variable. And let us also collect the expected results. The expected results is very simple. The final column data from this testing data set, if I capture, that is the expected result. That will be helpful for us to calculate the RMSE value. So we can calculate it. So now to do that very easy, again using the testing data set now. So if I extract the final column data, I should get all the, so here I will put semicolon, sorry, percentage, I will do this. So if I do, I will get all the output, expected output values. So right now there are some missing values here. So what we'll do here in this case is we'll also use one more inbuilt function where it will remove these missing values automatically. So I will use this inbuilt function called rm missing to remove the missing values. So yeah, we can say out of 121, these two values were missing. So in machine learning also those missing values should be ignored. So in our case this can also be done, but in my case right now, so if required we will use this, otherwise we will not use it. So now we know how to use it now. So we'll keep original data right now, but if required we know how to use the rm missing function, we will use it. So that depends on how many number of prediction results we will get. So if the missing value is ignored, I should get 119 predictions, but if this is also getting considered, so in the data, so then prediction value will also get for this. So based on that we will see what to do. So now let us do the work. So we will now predict the output using the inbuilt function. So we can use the inbuilt function of MATLAB called predict. This is the inbuilt function we are using. And right now the only trained model we have is this in the workspace. So it is automatically identifying the trained model. We'll select it. And it is asking give me the input data so that I can predict. All the input data are available in this testing data. So I can pass it. So I will pass the testing data as my input. And you can see, so we are getting 121 prediction results. So now we can calculate RMSE value. So first thing we have to do is we have to do very simple calculation for doing that. So we have to take expected result minus the predicted result, and then we have to square the result because mean square error. Then for this we have to calculate the mean value. So we'll calculate the mean value of this collection. Then we have to calculate the square root, that is the root mean square error. So I can store the RMSE value here if required. Okay, I am doing some syntax. Sometimes this error can come. Let us see. So we can see the error message and we can try to debug. So for me, so we are taking a table data where we are taking the table data here expected result. So to convert that as this is a matrix. So convert that as a matrix using this function it is telling. So this is a table data. So for this table data, you can use an inbuilt function for this to reduce the error. So let us use it, table to array, and we'll put it across this table. And now let's calculate. Okay, so now we have to use the power correctly. So it should not do matrix power, we should do element by element power. So we have to use a dot before the operator. This is one more syntax in MATLAB. If you don't do that, it will do matrix calculation. So right now you can see this is the result. Why? Because of NaN values in your collection. Now how to use this? How to avoid this? So very simple, we are using a mean function here, and here I can use a property called as minus, sorry, not here, after inside the mean function. Here I can use a property called omit missing, ignore the missing values. I can use this property. I'm using where to show you that properly. So I will expand the coding area. You can see I'm using inside the mean function. After I have given all these inputs, mean square, here I'm using the omit missing inside the mean function. That is where I'm using omit missing. It is an inbuilt property available in our statistical functions, where I can tell MATLAB to ignore the missing values. And now we can calculate RMSE value. You can see we are getting around approximately 3.4228, which shows the error value is on a good level, expected level. 3.4, 3.3, 3.4 were the expected result. Here also we can see we are getting similar expected result in the training, in the testing level also. So I hope everybody is clear with this. Yeah, so this is how we normally implement applications. So we don't full-fledged programming every time. So whenever, especially when it comes to these kind of implementation, we normally make use of app, find the best model, and then we'll generate the script which will help us give the program which will help us to implement that, and we'll simplify it using this section, and we'll automate this program. So here also, so this line also I can put semicolon. So these two lines we will just write it so that we can extract the inputs and output, means features and response. We'll train the model, and once we get that trained model, now we can easily test the model with our testing data set very quickly. We can verify it. So whatever the expected result we were getting, performance we were getting in training, like 3.3, 3.4 approximately, similar result we should also get in testing also. It should not be like here it is very good, and in testing it should not become very bad. That is what we expect. Similar, with minor deviation here and there, we should be able to get similar result. And here also we can see we are getting almost similar performance even in the testing also. If that is happening, so we are in a good means stage right now. If we want to improve it further, we have window to improve. We can see we can still minimize the error as much as possible up towards so negligible values, but still we can see we are getting similar performance. That is what is good way to verify that our model is not a overfitted model, it is a proper model. So that is something we have been able to easily verify. You have to check for overfitting. Right now we can see we are not having any overfitted model. So now we have been able to so verify that. So now what is next? Couple of things we can do. Now what I want to show you at this moment right now is so our team has used this kind of workflows for implementing end-to-end engineering domain applications. So I want to show you some of the applications that we have worked on. So we again I need internet connection to show you that, because my documentation is not installed locally. I am accessing the online documentation. So in latest versions of MATLAB, this is also there. In the older versions of MATLAB, documentation was part of your installer. It used to download GBs of documentation in your computer. But right now we have made the MATLAB lightweight, so the documentation will be online. You can see that in the settings in the latest versions of MATLAB. So you can see help documentation by default will be accessible in the internet. But if required, you want to make it offline, you can also download the documentation. It will take around some GB, 10 GB or something. It will download those documentation, and you can also access offline also if required. So once you download this, just restart the MATLAB. You can access the documentation offline also. So that is also possible. So I don't do that. I normally access through internet. So I normally, that is why it is always connecting to browser. Why? This is the reason. So let me check whether I can connect the Wi-Fi. No, this is not connected. So can I use this one? I'm not sure. LAN port ಇಲ್ಲ ನನ್ನ ಹತ್ರ. Let me check if I connect my mobile Wi-Fi internally. but my mobile Wi-Fi will be very low. Let's see. Try madana. We'll try. ಅದು ಆಫ್ ಆನ್ ಮಾಡ್ತೀನಿ.
02 ಯಾವ್ದು ಬಂದಿದೆ ಸರ್? 02 1 to 9
ನಿಮಿಷ 4 5 6 7 8 9 ಅಲ್ಲ.
ನೆಕ್ಸ್ಟ್ ಎಸ್ ನೆಟ್ವರ್ಕ್
Okay. Yeah, I think it is now connecting. So what I have done, I have accessed the help button like how we did earlier. So once I clicked on this, now you can see we have the documentation. So now here we will open the again same documentation here, AI and statistics. And right now, since we are focusing on machine learning workflows, we have understood right now here. Let us open the machine learning toolbox. And here you can see this is not only just machine learning toolbox, even you can do statistical applications also. Like if you want to do so descriptive statistics, data visualization, if you want to so fit your data with probability distributions, or if you want to perform hypothesis testing, all those things, ANOVA, all those things can also be implemented with this statistics library. But again, we also have machine learning libraries also, either for unsupervised learning process or supervised learning process. Both the methods you can do here. So if required, you can also perform feature extraction. You can also perform dimensionality reduction. So here you can see we have built some multi-domain applications here. So using this toolbox. So here we have given you some description here, what and all different areas we have covered. So you can see we have covered aerospace, biotechnology, so pharmaceutical, so communications, so energy production, signal processing, industrial automation, machinery, medical devices, finance applications also we have implemented, because we have also computational finance toolboxes. We have combined that with this library. We have implemented those kind of applications also. So here you can see now we have given you the applications that we have implemented here one by one. So you can also refer that. We have created multiple amounts of applications. So you can see that here, and we have also referred what and all domain specific toolboxes we have also used along with machine learning. We have also added those references also, so that you can ensure those toolboxes are installed in your machine before you access the example. If you have not have access to the toolbox, you can install the toolboxes and then you can access these applications. So you can see we have energy production applications here. Then we have industrial automation and machinery applications we have implemented. So here also you can see we have a EV application that we have implemented here. So this is not a complete EV, but in a way this is interconnected with EV. Especially we have focused on battery state of charge estimation using machine learning. So wherever you have battery based applications like robotics, EV, so this application can be helpful for you to integrate your EV means AI application with that. So this is the process we have done. We have a data set in this where we have data features like what is the voltage, current, temperature, average voltage, average current of your battery, and we can train the machine learning model with the output in our data set will be SOC, so which we want to predict in future. The idea is same. So you can see whatever inbuilt functions I have used, very similar to that. You can also see some of the functions, because this is an inbuilt data set, but idea is you can create your own data set also, and you can also do the same process. If required, we can help in that also if required. So we can help you to do that. You can try creating it. If you find it difficult, we can help you create the data set also. It's simple. So we are plotting some of the data. This is again data visualization they are doing in the programming itself here, but not compulsory. You can do different ways. So then you can see we are doing hyperparameter optimization for a specific model. They have directly gone for a specific model here. You can see they have gone for Gaussian process regression model, and they are so optimizing some of the hyperparameters of that model. So through programming, but we can see we can do this using app also without programming. That is also possible. So again, same result what we were able to see here also in script also you will get the graph. So then you will be able to see the best hyperparameter for all the features, which will be automatically loaded in your machine learning hyperparameter. So now you can perform the testing like how we did, and you can so calculate. You can see we have calculated RMSE, we have calculated standard error, mean means maximum absolute error, mean absolute error. So we can calculate those statistical parameters very easily like this, and we can plot. So here you can see we are doing almost same idea here. The idea is same, whatever we had done in basic application. Here also you can see the idea is same. Either your data set will change or your domain application will change. The base core idea in our MATLAB remains same. It doesn't change. So that is the whole idea here. So this is how we work with MATLAB. So we can implement core engineering applications very, very quickly. One more example I want to show you where we have also done integration of trained machine learning model in a Simulink application. To show that, what I will do here is I will use a search button here, and I will use the activity, means I know the title of the project, so I will, which we have worked on, it is called as human activity recognition. So let me search for that, so that I can quickly show. Yeah, it is human activity recognition. I will correct it. So it is activity, sorry. Why it is not searching? Now maybe I will get the result. Yeah, I'm getting the result. Yeah, so here you can see that example. So where we have captured sensor data. So using our mobile, because our MATLAB has mobile app called as MATLAB Mobile. You can also access MATLAB if you have online services in your license like campus wide license. So then you can connect the cloud service. So not online, sorry, MATLAB Mobile. You can connect those cloud service with your mobile also by downloading the APK file. It is supported in both Android also, Google means Android as well as iOS devices. It doesn't matter. You can go to the respective app store, open, search for MATLAB, and you should be able to download the APK file. It's a very small file. And why I use this very regularly? Why? Because so I can acquire sensor data, because our smartphone internally has multiple sensors. So I can capture images or video from my camera. I can capture audio data from my microphone. So internally, depending on the hardware you have, multiple mobile have multiple inbuilt sensors like gyroscope, accelerometer, IMU sensor, GPS sensor, proximity sensor. Multiple sensors will be available based on the hardware. So if you open the settings in your mobile, there also you will be able to see what and all hardware are available. You can also access those hardware using the app, log the sensor data, keep it in the cloud, and you can use the cloud data whenever you want. You can use the data whenever you want. That is also possible. So you can also see, you can also capture video, audio, images also if required, and you can create data set. So this is the reason why I use mobile sometime. I use MATLAB Mobile. I create data set using this kind of application. So similar thing we have done in this application also to show you that. So this is where you can see. So where we have given you the description, how we have collected the data set. So here we have given description. We have created data set. So we have created around 8,000 number of accelerometer signals. So by using volunteers for different human activities such as sitting, standing, walking, running. So our sensor will capture the data at a fixed means sampling rate. It is 10 hertz because I have used it. I know the default sampling rate in our MATLAB mobile app is 10 hertz, but if you want you can vary the sampling rate also. It's totally fine, you can vary the rate, but if you don't do it, by default it will be 10 hertz. So then we are doing feature extraction because this is signal data. So we are doing time domain feature extraction. This is part of signal processing toolbox we are using here to extract time domain features as well as frequency domain features. So for frequency domain features, how the frequency domain calculations has to happen, we are also defining that using our signal processing toolbox. So then we are extracting all those features from each and every feature extraction object we have created. We are extracting features for all the collection of signals at once. We are keeping everything together. So this is one thing I have not discussed in my application. So this is also something, whenever you have collection of data in MATLAB, we can use a concept called as data store. So that is something also I have not discussed, but in deep learning, this will be very, very helpful for us. So data store is a standard concept in MATLAB. So I will show that, so you can see that. So whenever you have any large collections of data, you can handle those large collections of data using a data store. There are different formats of data store. So right now, since feature data is a array data, so we are using a array data store to handle those features in a matrix format. That is what we are using here. Then we are reading all those feature data in a matrix. We are combining all those features in a single combined matrix. Then we are attaching the labels, whatever labeling we have done, it is available in the data set. We are extracting those and we are adding that in the final data set table. Then here you can see we are doing 75%, 25% partition. So we are doing the same. So this is something we will normally do. So your CV partition, what we are doing, so this will do randomization in the partition every time. So if you want to generate reproducible partition every time, so your random number generator should be set as a default. You fix the seed number of the random number generator. If you do that, if you add this line before you set up the partition, you can reproduce the same partition no matter how many times you run the script, you will get the same partition. No randomization will happen. If you don't want to do randomization, don't use this program. Randomization will happen. Whenever you want to recreate the randomization, just add this line, you will solve the problem. So that is something also you can do. So then again, this is a copy pasted section, not manually written. Using app, we have identified the model, whichever model we got best. We have copy pasted the program. You can see the section here. So we have copy pasted from the script, we generate, and then again training, testing, generating the. So for classification, we normally calculate accuracy, confusion chart, but in regression, we don't do confusion chart, we calculate RMSE value. So those kind of things we do, which we showed you. But in classification, we can also do this also. In classification learner also, automatically you will get this confusion chart generated. You can generate the confusion chart, you can observe these things, or you can write program also, and then also you can generate confusion chart like this. Multiple options are there. In this script, we have written program. So you can see here, using this function, we have generated the confusion chart. So multiple options are there. So you can build classification application also, regression application also. And so right now here we have got 95% overall accuracy for our application. So once we did this, we took it further. We took it one step further, and we started focusing on, can I do some application implementation on some hardware? So here we have used the support package for Android device. So where we have used this, and once we have trained the model, so we can take the trained model and we can build Simulink application like this. This model is accessible. You can access the model using this documentation. You can open the model also. I will show you how to do that. So you can see here, whatever the trained model we have, we can integrate it here. And using our hardware support package, we can access the mobile sensor data. We can calibrate the sensor data. We can put it in a buffer. We can extract the features using our feature extraction MATLAB script. You can see we are integrating MATLAB script here. MATLAB script here, MATLAB script here to access the trained model, to do the feature extraction, to calibrate the sensor data. So we are writing MATLAB script and we are combining that MATLAB script in the Simulink application. You can see the symbol. Whenever you see this MATLAB symbol, it is a MATLAB script which is running in the, means we are combining the MATLAB script inside Simulink model. And then we are accessing and observing the sensor data. And for that sensor data, what is the prediction we are getting? So we are also observing this in a GUI, that is in the Android device, as a video output. And you can see the screenshot here we have taken. So this is one of the result we have got for this series of XYZ acceleration data. So activity number is predicted as 2, which is nothing but standing application. Means we are standing for this sensor, it is predicted as standing activity. So like this you can so generate application, integrate into hardware. So this is also possible. You can integrate your AI application as a Simulink application at the end. It is not only limited to MATLAB program. Once you have written the MATLAB script, once you have trained the model, you can integrate that into Simulink application, which is very, very helpful in your hardware applications. So you can translate that into Simulink model and you can do hardware integration. So that is possible in MATLAB Simulink. So this is what industry focuses on. Industry focuses on building a model because hardware integration is very easy for us. So that is also something you have to think about. You have to, and you can see in MATLAB we have all those options. If you don't want to do hardware integration also, we have option. If you want to do hardware integration also, we have capabilities available through which you can realize those things so very easily. So this is how our toolbox works. Right now I have not covered deep learning, but in future we can also cover deep learning also. Deep learning also we can do. We can build applications very easily. So again, apps are available if you want to build custom. So one app I will recommend right now, maybe I will not be able to show you hands-on, but you can explore it further. If you want to build your own custom neural network, maybe CNN, maybe LSTM, no matter what, you can create your own custom neural network using this app called as a Deep Network Designer. And if you are focusing on hardware integration, you have to quantize those deep learning model also as a fixed point model. So that is also possible. We have deep network quantizer. You can so try to quantize the model and you can try to compress the memory size of the deep learning model as much as possible so that it is hardware friendly. So we have these apps available which will help you to simplify your deep learning applications also. So this is also something I highly recommend you to focus on. So we can, if there are any issues while you are working on these applications, we can help you also to do on this. So just a minute or two, I will open the deep network design and I want to show you few things which will be helpful to show you how extensively you can use our deep learning toolbox. So here I will show you the start page will open up. So we have our own inbuilt pre-trained models also, untrained models also. So for image, we have most of the pre-trained models are available in for image data, which can also be used for video data also. It's combined video and image. I use it for video applications also. It works totally fine. So you can see most of the popular models are in image networks. So in my offline, you can say I have not installed majority of the model. Default model will be SqueezeNet because this is a new version of MATLAB. In old version, I had installed multiple libraries, but in new version, you can see many of them are not installed, but you can install it. You can easily go. You can click on install. It will open the add-on library browser using your internet. You can see that, and you can log in with your MathWorks account and you can install these models very easily from our MathWorks server. You can see, you can install and you can access this networks very easily. Once the installation will be done, you can access this model and you can build applications with the model very, very easily. So that is something you can do. So whenever you see this kind of so symbol like this, that means the model is not installed. Just install the model and you can access the model. That's the idea. So right now, so you can see that is happening. Let it happen. So next is, you can see, if you want to even go for signal or time series data, we have LSTM networks also, sequence to label and sequence to sequence networks. If you are extracting features, so in deep learning, feature extraction is not compulsory, it is an option, additional option. You don't need to do, you can directly feed the raw data. Like if you have image data, video data, you can directly feed the raw data to this model. If you have signal data or time series data, you can directly feed the raw data here. Or if you have extracted the features, then you can also access our feature, so classification networks, to train our feature data and build applications. Then if you are working on audio applications, we also have audio specific models. So our deep learning toolbox has these domain specific models readily available. If you are happy with this, then you can use our networks. But if you have used Python and if you have a ready-made TensorFlow model ready, you can import those model in MATLAB. If you have PyTorch model readily available, you can import those models, make it available inside MATLAB, and you can use those models in MATLAB applications also. So that is also something you can do. We support integration of MATLAB with multiple technologies. Python is also one of the technology where we support integration in AI applications specifically. So you can do that. So that is also something you can focus on. If you have a ready-made model, then you don't need to waste the time. You can install the support package. You can see this support package is called, so deep learning toolbox converter for TensorFlow models, which will convert your TensorFlow model into MATLAB deep learning compatible version, and you can use it very easily. It works totally fine. So you can work on it. We have helped with multiple researchers. They have used it very extensively. They have been able to implement successfully. So similarly for PyTorch also we have a converter. So if you download, means not download, sorry, install the converter from the add-on explorer. If you click on it, again same thing, it will open the documentation. You can install it, and once the installation is complete, you can use our documentation and so work with the existing models very easily. So that is also possible. So multiple options are there in our MATLAB. The idea here is, depending on what you want to do, you will always have multiple options available. So whichever method is easy for you, you can explore it, identify it, and you can start implementing those things one by one. So that is how MATLAB works. So that is also something we recommend you to explore those things, try to do those things. And again, if you find any difficulty, you can write to our email ID. uh, any one of our team member will be definitely will be helping you to solve those issues. So that's it from my end right now. So if anybody has any questions, you can let me know. We can take questions if any questions are there, because yesterday also we have covered EV application. Today we have covered AI applications, uh, and we have given some idea how you can integrate with Simulink, how you can build engineering applications with our machine learning, deep learning. We have given some idea here now. So if you have any questions right now, you can ask questions.
I hope there are no doubts. Thank you, Rakshit. All of you, if you have any doubts, any support you want in future, you can get down his email ID. Okay, I think yesterday he had shared already email
I can
ID.
share it once again.
Once again, you can take and you can encourage your university's management to purchase campus-wide license, because most of the students they use pirated version. Okay, so because of that, they are not supporting. So these Corel people will support if we have a license. This is a problem.
One more disadvantage is, in pirated version you cannot do hardware integration.
Hardware integration.
You can only do software based application.
At least you can tell your whole organization, like Columbus University is a big university. if you purchase a campus-wide license, all departments, irrespective, any person can use it from their email ID domain. Now we are doing it here. And when we purchase campus-wide license, they will support. And if you don't have license, then they are not authorized to support. That is a problem. Okay, and for campus-wide license, now rates are reduced drastically. Okay, so they will come and even they give workshops to the students if you have a campus-wide.
Yeah. So if you want to talk about pricing details, we have Mr. Bhanu Prakash, who is the territory manager of Karnataka. So you can contact him. His name is Bhanu Prakash Dikshit. So his email ID is bhanu.p@corel.com. You can also reach out to him as well. If you write to my email ID, I can also share his contact number also. You can also have a call with him on phone also if required. If email is not supported, you can write to me. I can share his contact number also.
Because before campus-wide license, we were having perpetual license. Perpetual license have some limitations because students have to come to lab only and they have to do years. So now our students, they all work from the hostels only if they have campus-wide license. What they need is only email ID
and internet connection.
Internet connection. That is the advantage of campus-wide license. Costing is almost same. Perpetual and campus-wide license costing is same, but from the day one you will get the latest version. If any model is launched today, tomorrow you can start using it. This is the advantage of campus-wide license. Okay, so I thank Rakshit for your valuable time, and always he comes yearly once or twice to our campus. And especially his last time he already showcased some hardware integration also, and we purchased some FPGA boards from Core Technologies. Our research scholars are working already. The Spartan 7 and Zinc board. No, I purchased one Zinc board.
Zinc board.
Electronics people they purchased one Spartan 7. Okay, so that is what he was telling. If we have license version, then we can interface.
Yeah, for FPGA, we have a Xilinx AMD Xilinx team separately. We are MATLAB team. Similarly, we have AMD Xilinx team. So if again you can write to my email ID, we'll connect to the AMD Xilinx team also. We have technical team again. You can identify the hardware and you can connect to sales team, which will help them to. So pricing details they will be able to give you. They will definitely help in that.
That's all. Thank you. Now I will request Vijay sir to hand over the token of love and appreciation to Rakshit. Please, sir.
Thank you very much, sir.
My pleasure, sir. This is your number also.